Interduct, which is high-density polyethylene tubing, is approved for certain underground installations as an alternative to polyvinyl chloride, commonly known as PVC conduit. However, it's essential to understand that it's not a universal replacement for all PVC conduit applications, but rather a suitable option in specific scenarios. Interduct's approved uses for underground installations include firstly communications cables, secondly fiber optic cables, thirdly low voltage electrical cables up to 600 volts, and fourthly medium voltage electrical cables up to 5000 volts. Conversely, Interduct is not approved for high voltage electrical cables exceeding 5000 volts, power cables, gas lines, and water lines. Approved fittings designed specifically for underground Interduct installations do exist. These fittings are typically constructed from the same material as the Interduct tubing itself, ensuring a watertight and durable connection. Proper installation practices are paramount. When utilizing Interduct for underground installations, meticulous adherence to the manufacturer's instructions is crucial. This includes the correct selection and application of fittings and installation methods. Failure to comply with the manufacturer's guidelines can compromise the integrity of the installation, potentially leading to safety hazards or damage to the cables. It is crucial to acknowledge that Interduct is not a direct substitute for PVC conduit in every situation. PVC conduit offers greater rigidity compared to Interduct, making it more suitable for applications subjected to heavy loads or significant mechanical stress. Conversely, Interduct's flexibility makes it advantageous in confined spaces or scenarios requiring resistance to bending or movement. To summarize, Interduct can serve as a viable alternative to PVC conduit for specific underground installations. However, careful consideration of the application's unique requirements and strict adherence to the manufacturer's instructions are essential for successful implementation. When deciding whether to use Interduct or PVC conduit for an underground electrical installation, there are several factors to consider. These factors include the type of cable being installed, the voltage of the cable, the environmental conditions at the installation site, and the budget for the project. Let's delve into a more detailed examination of these considerations. Firstly, the type of cable being installed is a significant factor. Interduct is approved for use with communications cables, fiber optic cables, low voltage electrical cables up to 600 volts, and medium voltage electrical cables up to 5000 volts. It is not approved for use with high voltage electrical cables above 5000 volts or power cables. If you are installing high voltage or power cables, you will need to use PVC conduit or another approved type of conduit. Secondly, the voltage of the cable is another important factor. Interduct is approved for use with low voltage and medium voltage electrical cables. If you are installing high voltage electrical cables, you will need to use PVC conduit or another approved type of conduit. Thirdly, the environmental conditions at the installation site should be taken into account. Interduct is resistant to moisture, chemicals, and UV radiation. It is also able to withstand extreme temperatures. If the installation site is exposed to these types of conditions, Interduct may be a better choice than PVC conduit. Fourthly, the budget for the project is always a consideration. Interduct is typically less expensive than PVC conduit. If you are on a tight budget, Interduct may be a good option. In addition to these factors, it is also important to consider the National Electrical Code, or NEC, requirements for underground electrical installations. The NEC specifies the types of conduit that are approved for use in different types of installations. It also specifies the minimum burial depth for underground conduit. Before beginning any underground electrical installation, it is important to consult with a qualified electrician to ensure that the installation meets all applicable codes and regulations. When installing Interduct, you must use the correct fittings. These fittings are designed to create a watertight seal and protect the cables from damage. You should also use a lubricant when installing Interduct to make it easier to pull the cables through the conduit. The NEC, as of 2014, provides specific guidelines for underground installations of both Interduct and PVC conduit. These guidelines cover aspects like burial depth, conductor fill, and support requirements. For example, NEC Section 300.5 outlines the minimum cover requirements for direct buried cables and raceways, which varies based on voltage level and installation location, such as under buildings or roadways. It is imperative to consult the latest edition of the NEC and local electrical codes to ensure compliance with all applicable regulations. Proper grounding and bonding are also essential for safe and reliable electrical installations. The NEC Article 250 provides comprehensive requirements for grounding and bonding electrical systems. When using Interduct, ensure that all metallic components are properly grounded and bonded to prevent electrical shock hazards. Furthermore, it is crucial to protect the cables from physical damage during and after installation. This can be achieved by using warning tape or concrete encasement to protect the conduit from accidental digging or other physical disturbances. The choice between Interduct and PVC conduit ultimately depends on the specific requirements of the installation. Carefully consider the factors discussed above and consult with a qualified electrician to make the best decision for your project. In the context of underground electrical installations, understanding the specific applications for which Interduct and PVC conduit are best suited is crucial for ensuring safety, compliance, and long-term reliability. Let's delve deeper into these applications and the factors that influence the choice between these two materials. Interduct's flexibility and resistance to chemicals make it particularly well suited for applications in challenging environments. For instance, in areas with soil contamination or high moisture levels, Interduct's inertness and watertight connections provide enhanced protection for electrical cables compared to materials that may corrode or degrade over time. This makes Interduct a preferred choice in industrial facilities, wastewater treatment plants, or agricultural settings where exposure to corrosive substances is common. Conversely, PVC conduit's rigidity and strength make it ideal for installations where physical protection is paramount. In high-traffic areas or locations where the conduit is susceptible to mechanical damage, PVC conduit provides a robust barrier against impacts, crushing forces, and abrasion. This is particularly important in applications such as underground installations beneath roadways or parking lots, where the conduit may be subjected to heavy loads and vibrations. Furthermore, PVC conduit's resistance to flame propagation makes it a preferred choice in applications where fire safety is a concern. PVC conduit is designed to self-extinguish, preventing the spread of fire along the conduit pathway. This is a critical consideration in buildings and facilities where fire protection is essential, such as hospitals, schools, and data centers. In addition to these application-specific considerations, the type of wiring method used in the installation can also influence the choice between Interduct and PVC conduit. Direct burial cables, for example, may be suitable for use with Interduct in certain applications, provided that the cables are specifically listed for direct burial and meet the requirements of the NEC. However, in other cases, it may be necessary to install the cables within a conduit system for added protection and support. The conductive fill capacity of the conduit is another important factor to consider. The NEC specifies the maximum number of conductors that can be installed within a conduit of a given size. This ensures that the conductors are not overcrowded, which can lead to overheating and potential electrical hazards. When selecting between Interduct and PVC conduit, it is essential to ensure that the chosen conduit size is adequate to accommodate the number and size of conductors being installed. Furthermore, the bending radius of the conduit is an important consideration, particularly in installations where the conduit needs to be bent around obstacles or corners. Interduct's flexibility allows for tighter bending radii compared to PVC conduit, which can be advantageous in confined spaces. However, it is important to ensure that the bending radius does not exceed the manufacturer's recommendations, as this can damage the conduit and compromise its structural integrity. Finally, the overall cost of the installation is always a factor to consider. Interduct is typically less expensive than PVC conduit, which can make it an attractive option for budget-conscious projects. However, it is important to weigh the cost savings against the potential performance trade-offs such as reduced physical protection or limited application scope. It is always advisable to consult with a qualified electrical contractor to assess the specific requirements of the installation and determine the most appropriate conduit material and wiring method. A thorough understanding of the application requirements, NEC regulations, and material properties is essential for ensuring a safe, compliant, and reliable underground electrical installation. Additionally, it's worth noting that advancements in materials and installation techniques are constantly evolving. Staying informed about new products and methods can lead to more efficient and cost-effective solutions. For example, some manufacturers offer pre-lubricated Interduct to ease cable pulling, while others provide specialized fittings for challenging connections. Always consult the latest product literature and technical specifications to ensure that you are using the most up-to-date information. Also, consider the long-term maintenance requirements of the installation. While both Interduct and PVC Conduit are relatively low maintenance, periodic inspections can help identify potential problems before they escalate. Look for signs of damage, such as cracks, punctures, or deformation, and address them promptly to prevent water ingress or other issues. Consider the use of tracer wire alongside the Interduct or PVC conduit. A tracer wire is a metallic conductor that is buried alongside the non-metallic conduit. This wire can be used to locate the conduit underground using a metal detector. This is particularly useful for future maintenance or repairs, as it eliminates the need to dig blindly in search of the conduit. Furthermore, document the location of the underground installation accurately. Create a detailed site plan that shows the location of the conduit, including its depth, route, and any splices or connections. This information can be invaluable for future maintenance or modifications. When backfilling the trench after installing the Interduct or PVC conduit, use caution to avoid damaging the conduit. Use a fine grey material such as sand or gravel to backfill around the conduit and compact the material in layers. Avoid using large rocks or debris, as these can puncture or crush the conduit. Consider the use of concrete encasement for added protection, especially in areas where the conduit is subject to heavy loads or physical damage. Concrete encasement involves surrounding the conduit with a layer of concrete, which provides a robust barrier against impacts and crushing forces. This is particularly useful in areas where the conduit is buried under roadways or parking lots. In areas with expansive soils, consider using expansion joints in the conduit run. Expansive soils can swell and shrink with changes in moisture content, which can put stress on the conduit and cause it to crack or break. Expansion joints allow the conduit to move with the soil, preventing damage. When making connections to electrical equipment, use appropriate fittings and connectors. Ensure that all connections are watertight and corrosion resistant. Use a torque wrench to tighten the connectors to the manufacturer's specified torque to ensure a secure and reliable connection. Consider the use of surge protection devices to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment, especially in areas with frequent lightning strikes or power grid disturbances. Surge protection devices can divert excess voltage away from the equipment, preventing damage. Furthermore, remember that safety is paramount when working with electrical systems. Always to energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves, eye protection, and hearing protection. Follow all applicable safety regulations and guidelines. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take precautions to prevent accidents. By carefully considering all of these factors, you can ensure that your underground electrical installation is safe, reliable, and compliant with all applicable codes and regulations. Remember to consult with a qualified electrician or engineer if you have any questions or concerns. Their expertise can help you make the right choices for your specific application.